We're going to talk about equation solving techniques. So we're going to have different types of situations and we're going to learn techniques to solve those equations. So we're going to start with radical equations, which will have like a square root involved, or it might have a cubed root. And we're going to learn the ways to deal with this. The steps that you're always going to follow is first, isolate the radical. Second, get rid of the radical by doing the opposite of both sides. And I'll show you what I mean by that when we work out some examples. Third is solve the equation. And fourth is check the solution in the original equation. That's very important because a lot of times you'll get more than one answer, but when you plug them back into the original, only one of them is actually true. So let's look at this first example. I have the square root of 15 minus 2x equals x. I'm going to start by squaring both sides. I don't have to isolate the radical because it's already by itself. So I'm going to square both sides to get rid of that radical. So a radical is really to the second root or to the 1/2 power. So I can undo it by squaring it. So if I square a square root, it's going to actually undo itself and leave you with what's just under the radical. So I've got 15 minus 2x equals x squared. Now, just like in the previous section where we had quadratics, now I have a quadratic without a radical. I'm going to get it set equal to 0. I'm going to add 2x to both sides and subtract 15 to both sides from both sides. So those will cancel and leave me 0 equals x squared plus 2x minus 15. Now I can factor this. So I've got x. I need factors of 15 that add to be 2, positive 2. So that's going to be positive 5 and negative 3. That will give me the positive 2x in the middle. So if you FOIL that, if you want to check, it'll go back to that original equation. Now you're going to set each factor equal to 0. So I've got x plus 5 equals 0. When you subtract 5 from both sides, that gives you x equals negative 5. So that's one solution. And then I've got x minus 3 equals 0. I add 3 to both sides. That's going to give me x equals 3. So those are my two solutions. Now I want to check those back in the original equation. So let's look at negative 5 first. If I plug that into the equation, I've got 15 minus 2 times negative 5 equals negative 5. Just plugging in negative 5 for x, which is going to give me 15 plus 10 equals negative 5, which will give me the square root of 25 equals negative 5, which means 5 equals negative 5. Well, that's obviously not true. So our x equals negative 5 does not work here. So if we check the other one, let's check x equals 3. You're going to have 15 minus 2 times 3 equals 3. That's going to be 15 minus 6, which will be the square root of 9 equals 3. And that does come out to be true. 3 equals 3. So here, your x equals 3 is the solution that works back in the equation. So don't just solve it and say you have two answers. Make sure you go back and check them in the original. Okay, we're going to use a similar method on this next example. You've got, let me erase some of this so you can see it better. We've got the square root of x plus 3 minus 3x equals negative 1. Here, we do need to isolate the radical, get this by itself, so I'm going to add 3x to both sides. So that's going to give me the square root of x plus 3 equals, and I'm going to flip that around so I've got 3x minus 1. You don't have to do that, but it just puts it in order. Now, since I have the radical isolated, I'm going to square both sides to get rid of the square root. And when I do that, that's just going to give me x plus 3 on the left. And then I need to FOIL the 3x minus 1. Multiply it by itself when you square it. So you're going to have first would give me 9x squared. Outside would be negative 3x. Inside would be another negative 3x. And last would be a positive 1. So that's going to give me 9x squared minus 6x plus 1 on the right. So now I've got everything's FOILed out. I've gotten rid of the radical. So now I've got a quadratic. I want to get it set equal to 0. So I'm going to subtract x from both sides and subtract 3 from both sides. So I'll have 0 equals 9x squared minus 7x minus 2. And I can factor this. I'm going to do the method we did in the last section where I take the multiply a and c together. So 9 times negative 2 is going to give me a negative 18. So the factors of negative 18, I could have 1 and 18, 2 and 9, or 3 and 6. The ones that will give me negative 7 is going to be the 2 and the 9, where the 9 is negative. So I'm going to unadd the negative 7, so I'll have 2x minus 9x, and then bring down your other two terms. So I've got 9x squared plus 2x minus 9x minus 2. And that equals the 0. So this is the same equation. I've just rewritten the negative 7x so that I can factor it or I can regroup it. So I'm going to regroup and see what I can pull out of the first set of parentheses. I can only pull out an x. And then I'll leave a 9x plus 2 on the inside. And on the second one, the only thing I can pull out there is a negative 1, which is just going to change the signs. But notice I've got 2 of the same linear factors. That's what needs to happen. That's going to be one of my factors. If those aren't the same, you've done something wrong. And then what's left over on the outside is your other linear factor. So this factors into 9x plus 2 times x minus 1. Now that's the method I showed you in the last section to factor that quadratic. You can also guess and check and just, if you were going to factor this, you could just guess and check. As far as factors of 9, you could do 9x and 1x and 2 and 1, or 3x and 3x and 2 and 1, and just switch those around until you got the correct 2 linear factors. So either method is fine. You can guess and check, or you can do the method I showed you where you have to regroup and factor out the greatest common factor. Either way, you'll come up with two linear factors, and at that point, you're going to set them equal to 0. So here I've got 9x plus 2 equals 0. I'm going to subtract 2 from both sides. And I've got 9x equals negative 2. Divide by 9. And that gives me x equals negative 2/9. Then the other one, I've got x minus 1 equals 0. Add 1 to both sides. And that'll give me x equals 1. So I've got two solutions here. Again, you're going to want to check. If you plug these back in there, I'm just going to show you right here. Let's do the easy one first. If we have x equals 1 and we plug it in the original equation, you've got 1 plus 3 minus 3 times 1 equals negative 1 in the original. So I've got the square root of 4 minus 3 equals negative 1. So that's going to be 2 minus 3 equals negative 1, which is true. Negative 1 equals negative 1. So that one works. If you check the other one, x equals negative 2/9. You're going to have the square root of negative 2/9 plus 3 minus 3 times 2/9 equals negative 1. This one's a little uglier because it's a fraction. But if I change my 3 into, get a common denominator, I've got to multiply both top and bottom by 9. So I'll have 27/9 minus, this will be 6/9. You just multiply across. This will give me 25/9 minus 6/9. That'll be 5/3. When you take the square root of it, you just take the square root of the top and the square root of the bottom. And then that 6/9 will reduce to 2/3 equals negative 1. And then if you combine 5/3 minus 2/3, that's going to give you 3/3, which is equal to 1, does not equal negative 1. So in this case, your 2/9 does not work. So the only solution is x equals 1. Okay, let's do one more of those. This one's a little trickier because it has two radicals. So you're going to pick one of them to isolate. Doesn't matter which one. I'm going to subtract the square root of x minus 2 from both sides to get the square root of 2x plus 3 by itself. And that's going to be 4 minus square root of x minus 2. So I've got one isolated. Now again, I'm going to do what I did before. I'm going to square both sides. So this side, the left side, gives me 2x plus 3. And on this side, you would need to FOIL this because it's times itself. So you're going to have 4 minus the square root of x minus 2 times 4 minus the square root of x minus 2. So when you FOIL this, it works just like what we did before. When you do the first term, it's 4 times 4 is 16. outside would be 4 times the negative square root of x minus 2. So I'm going to have negative 4 square root of x minus 2. And then inside, I get the same thing. And then last, it multiplies by itself. So it's a negative times a negative, so it'll give me a positive. And when I multiply a square root by itself, it just gives me what's under the radical. So the square root of x minus 2 times the square root of x minus 2 is the same thing as squaring it. So that's going to give me 16 minus, I can combine these because they're like terms, so that's going to be 8 square root of x minus 2 plus x minus 2. And then I can combine my 16 and my negative 2, which will give me 14 minus 8 square root of x minus 2 plus x. So that's what I get when I FOIL the right side. So now I've still got a radical in my problem, so I'm going to do the same thing. I'm going to repeat the steps by isolating the radical again. So I'm going to subtract x from both sides and subtract 14 from both sides. So that's going to give me x minus 11 equals negative 8 square root of x minus 2. Now here I'm going to, if I divided by negative 8, which I could do, it would be kind of messy. So I'm just going to go ahead at this point and square both sides. And that's going to give me, I need to FOIL this, so it's going to give me x minus 11x minus another 11x plus 121. And then when I square that, it's going to give me 64 times x minus 2 without the radical. So now I'm going to combine like terms and get everything on one side. So I've got x minus 22x. Oh, I'm sorry, that should be an x squared. So x squared minus 22x plus 121 equals 64x minus 128. I'm going to get it set equal to 0 by subtracting 64x from both sides and adding 128. So I've got x squared minus 86x plus 249 equals 0. Now if you factor this, it looks kind of nasty, but 249 will actually, if you take the factors of 249, 1 times 249 is not going to give you the negative 86. 2 won't go in it, but 3 will go into 249 83 times. And that will give you the negative 86 if they're both negative. So if I've got my linear factors, I'm going to have x minus 3 and x minus 83 will be my two linear factors. And then again, you can solve that. Set each one equal to 0. So you're going to have x equals 3 or x equals 83. And again, you're going to check these back in the original solution. If you check these, the 83 does not work, but the 3 does. And if you look at the instructor notes, I have that worked out on the paper. We're going to do an example of rational exponents in the next video.